Hare Krishna. This is first video on my design pattern series. Today we are going to learn about state design pattern. So without further ado, let's get into the video. So basically, as we know, like design patterns there to solve a problem, right? So they were already well tested, okay, and they were proven, okay, if this sort of situation comes, okay, you can go with this pattern. So in the same way, like state design pattern also exists to solve a particular problem. State design pattern. So basically state design pattern comes under behavioral design pattern category. Okay, so it allows, excuse me, it allows an object to alter its behavior when its internal state changes. So basically the object behavior depends on its internal state, depends on internal state. So when internal state changes, then it changes its behavior. Okay. On a high level, like this is what the state design pattern is all about. So this pattern represents states as separate classes. When we say state design pattern, right? So it always about states. Okay, when I say states, example, we take traffic light. Okay, traffic light. So what are different states we can observe there? So red, which indicates, okay, a vehicle should stop and pedestrians can go, right? Can walk, I mean to say. Then there is a green, that means a vehicle can go. Then there is an yellow, which indicates like it's going to be stop, right? So the vehicle driver or else the rider should be ready to stop, right? So basically, these are three states. So depending upon these states, so we generally follow the traffic rules, right? So in the same way, when we talk about state design patterns, it also depends upon these states. This is just an example, traffic light here. Okay. So basically, we do have separate classes for each state. Okay, example here, red, green, yellow. So here the traffic light is the main aspect and it has three states, red, green, yellow. So now we define this in three different classes. Maybe you can think like red state class, green state, and then yellow state. Okay, and this traffic light delegates the state specific behavior to these classes. Okay, and why basically we need this state design pattern? So basically this helps to keep your code clean. Okay, the so-called if-else conditions there, right? So there are multiple if-else conditions we do, right? So you can get rid of this if-else condition chain. Okay, chain of if-else conditions, I mean to say. So basically you can keep the code clean and organized and more maintainable. Okay, by reducing these conditional statements and promoting a more object-oriented approach. Okay, so on a high level, like this is what a state design pattern is all about, right? So we'll see how our code looks without state design pattern and with state design pattern in live. So now if you look at my screen, design patterns, yeah. So here it is an ugly code without state design pattern. So basically I have a computer one. Okay. This is a class. So there is a boolean is on. I'm setting it to initially false. So I have two methods power on and power up. So if this is not true, then that means turning on the computer and then I make it true. Else I make it it's already on. So then here also the condition is checked. You can see here, right? So to perform the power on, power off, sleep, how many if else conditions you are writing. So this is just a sample example, okay? In your real-time production code and your real-time problem, okay, there might be n number of conditions comes into the picture, or else there might be a complex states which can represent an object, right? So it's not so ideally good suggestion or is good code practice to write these many if else conditions to deal the object state change. Okay. So now if we see here computer one, okay, power on, sleep, power off. So basically it's going to display and it comes here, okay, it checks if it is on or not. If it is already, sorry, if it's not on, then it turns and make it true, right? So what are the disadvantages with this kind of code? The first and foremost thing is complexity. Okay. As the system grows and number of states and transitions increases, right? Managing all conditional statement becomes more complex and sometimes it leads to error prone, right? So now here only two we have, okay, it looks maybe easy, okay, but if your states and transitions are increasing, okay, it becomes too tough to deal these along with your conditional statements, okay. There might be some situation where you end up having a sonar, or what I can say, code smell also like cognitive complexity due to the high rise in the conditional statements inside a method. Okay, and then maintainability also one of the disadvantages. If you want to add new states or modify the behavior of the state behavior based on the state, right? So you will need to change multiple places in your code, right? Because this is how like currently it's behavior. So now maybe someone say, okay, if it is true, then only on, otherwise don't on. So if the behavior changes, like you need to do so many changes in your code, right? So potentially you need to rewrite your test and so many other things also. Then readability, the code becomes less readable as it's cluttered with conditional logic, right? So making it harder to understand and maintain. So someone who comes as a new developer, new joinee, so he feels like frustrated. Okay, let me leave man this alone. Okay, he won't even try to touch these things. So these are the couple of disadvantages with this kind of code, right? So please do let me know if you have other things in your mind about these things. Now, the state design pattern addresses these issues, okay, by encapsulating the behavior of each state in separate classes, okay. So, because of this, like it allows us a cleaner, more maintainable, and extensible code, okay. It centralizes the state specific behavior. That's what I said. So, state specific behavior and simplifies the management of state transitions, making the code easier to understand. Okay. Now you might got some clarity, right? Now let's see how we can write this code with the help of state design pattern. Okay, so basically now what I'm going to do here is I'm going to deal with a computer. So computer has three states. If you agree with me, a computer has three states. What are those three states? One is nothing but on, another nothing but off, another nothing but standby. That is nothing but sleep. Okay, standby. Okay, these are three kinds of state computer has. So now let's see how our code looks. So basically here is a state interface. Okay, so power on, power off, and sleep. So these are the three common methods, right? I need across the different states. Okay, so just I created an interface. Now we'll see how our on state looks like. Okay, on state implements the state, and you observe it implemented this power on, power off, and sleep methods, and you see computer is already on. When it is in on state, and someone trying to power on, that means it's already on, right? So you cannot do anything there. Power off, yeah. In that case, since it is already on, then you can power off it. Sleep, yeah, you can put your computer into sleep. That's fine. Then off state. When it is in off state, right? So turning on, yes, it works because it is off, you're turning on. Great. But if you're trying to power off, since it is in off, like it's already off, right? You cannot do. Then sleep, computer is off. It cannot be sleep because like it's already off, right? So sleep cannot work out there. Then standby state, that is nothing but our sleep state. So when it is in standby, when someone trying to on it, yes, it can waking up from what I can say standby. If someone trying to off, yes, it can be turn off from the standby. If trying to call sleep, then no, it's already in sleep. That means standby. So it cannot do the same operation. So this is how three states are there and the interfaces. Now see the client code. So here is a computer class which has a reference to our state. So initially, what I can say, I using the off state. Okay, I am initializing in this constructor, but we'll learn like how we change this dynamically. Okay, so I do have a set state method, so which can take a state and then what I can say set it. And on the state, whatever I set to this, whether it may be on, off, or standby, I have three options. I can call power on, power off, sleep. So which eventually calls the that particular implemented state power on, power off, and sleep methods, whatever it is, on state, off state, or standby. So now we'll come and see the main app code. So here it is. So I created an object for computer and initially I'm calling on sleep off. If we carefully observe in my constructor of computer, so I initialize it to off state. So whenever I'm trying to call here power on, sleep, power off, that means this comes from off state. Okay, power on means turning on the computer. Computer is already off, and then this is. Then what I'm doing here is I am setting the state to the on state. So as we can see, like we have a facility to set a new state, right? Set state method we have, so it can take a state and then it can assign it back to the this state. Okay. So what I'm doing here is like I'm passing on state. So when I'm passing on state, I'm trying to call power on, sleep, power off. So when I'm trying to power on, no, it's already on. Power off, yes, it can turn off. Sorry, sleep. That means uh, here it is this one putting into sleep and then turn off. Then here it is turn off. Cool. So now we'll try to run it. And this is how our output should look like, the order of the uh, I mean to say like the system.out.println, whatever we wrote. We'll quickly verify those now. So first is turning on the computer. Yes. 1 second. Computer is off. Cannot sleep. Yes. Uh, it's correct because I'm calling here sleep. I just what I can say misplace these things, but yeah, we can see in the off state. Okay, what the output for sleep. Computer is off. Cannot sleep. Right? It's correct. Then power off. What is there in power off? Computer is already off. Computer is already off. Okay, yeah, these three things are correct. Then the computer is already on, putting the computer to sleep, yes, turning off the computer. So it works fine, right? So now tomorrow, if you would like to make it standby, okay, what you need to do? You need to just set that state to the standby. That's it. Standby state. Cool, you're done with that. Now, when it is in standby, what is your expectation on power on? Waking up, right? So let's make it waking up. What is your output on sleep? Here it is. Computer is already in standby. Computer is already in standby. What is your output on? Sorry, that's for sleep. Okay, computer. Then off. Off means like turning off the computer by standby. Sorry. Okay, cool. Now we'll quickly check these three statements also, the last calls. Okay, waking up and then computer is already on, turning off. Okay, it's looks great, right? So now you might be wonder, right? So what exactly the sort of benefits we are getting from this piece of code? So the first and foremost benefit from this is with state pattern, the benefits of implementing polymorphic behavior are evident. That means runtime you are detecting the behavior and they are evident now, right? And it is also easier to add states to support additional behavior. So tomorrow someone say like can you please add another state, maybe some music mode. Okay, that may be a kind of state. Let's hypothetically think, okay, where your computer plays only the music, it don't do anything. So you no need to touch any of these things, right? You just go here, okay, and you just create a new class, okay, which implements the state method and then implement overrides this all three methods. So that's as simple as it is. Then the state pattern, okay, promotes cleaner, more organized code by separating the each state's behavior in its own class. This separation makes your code easier to understand and maintain, right? So now when any new developer comes, right, he no need to do anything. He just focus on this call and this caller. That's it. I mean, it's a computer class. Okay. Now he can say, okay, there is a state. Okay, this might be a interface. He goes, okay, it has three methods. Cool. then I'm having this state. Okay, if he knows this automatically state, right, then he can see who implemented this state interface, right? So here it is saying three implementation, and if he click on that, he can find able to. So the what I can say notable point here is like it's promoting more cleaner and organized code. That's the main thing. Then when you need to add or modify states or behaviors, the pattern makes it easier to do so without affecting the existing code. This modularity improves code maintainability, right? So when someone say, okay, now when it is in off state, so instead of printing turning on the computer, let's print something starting the computer. Some changes to the existing one. So you no need to touch any other things, right? It doesn't break anything. So it's more like modular way of designing. Now, the state pattern allows you to add new states, change behavior of existing states independently, making your code more flexible and adaptable to future changes. Yes, that's what we are able to see, right? Then code with the state pattern is typically more readable because the behavior for each state is contained in a single class, reducing the complexity of conditional logic in main code. So this is what we are keep on understanding. So now we have three states and we created three new classes, and then these three new classes dealing these three new states. So then there is no more this conditional logic check. Okay. So much of, and it reducing the complexity. The pattern can help reduce the risk of bugs related to state transitions and behavior changes because each state is isolated, yes, tested independently. So tomorrow, if some new state comes, okay, you're adding or modifying, you're deleting, whatever it is, it doesn't break your existing code, right? Because these are well isolated and they are tested independently. They can be tested independently. So you no need to worry on these things. However, everything has in the life positives and negatives, right? So far we've seen some good things. Now let's see. However, it's an essential to consider the trade-offs. Okay, in if your system has only few simple states and transitions, introducing the state pattern may add unnecessary complexity, right? Because let's say you have payment mode in your application. All you know is today you can accept either Google Pay or Phone Pay. Okay, example, hypothetically thing. So it has very few states and transitions. Then you don't need this state design pattern because it's unnecessarily add some complexity to your code. Okay. In such cases, using simple if statements may be more pragmatic. Okay. Now, state pattern is most beneficial in these scenarios. Okay, you can consider these scenarios when you are going to choose state design pattern. Your system has many states with complex behaviors. Okay, the sentence itself is saying. I don't need to explain anything. State change frequently and dynamically. So there are some sort of situations where your object state can change very frequently and dynamically. So there you need to consider state design pattern. You anticipate future changes in states or behavior. Okay, today you are developing with Google Pay and Phone Pay, but you have that anticipation like, okay, tomorrow they can come and ask to implement a Phone Pay, or else like, sorry, Paytm, or else some Yono, or else some UPI, or else cash on. So maybe some other kind of states for this payment mode can comes into the picture. So if you anticipate future changes, right, then you can go with state design pattern at early development only. Okay. Then you need to consider this when you are more concerned about core readability, maintainability, and flexibilities are high priorities for you. Okay. It's more upon developer how he takes these design patterns into the consideration. So this is all about this first video on design pattern series. So I'm going to upload more videos coming days on the design patterns, and we slowly, what I can say, transition towards solving a low level design for particular problems. Till then, don't forget to subscribe and don't forget to tap the bell icon so that you won't miss any notifications when I upload a new video. Finally, Hare Krishna.